Hello, my dear students. Good morning, all. How are you? So, schools are opening. Are you ready to go to schools? Definitely. You are very interesting to come to school. Is it? Yes, very good. So, in the last sessions, we are discussing about the concept of atoms and molecules. So, today also we continue the same lesson with different subtopics. Okay, children? Already you know myself, B. Radha Devi, working as a physical science teacher at KGBV, Kallur. So, shall we start our online class? Okay. So, first, let us recapitulate our previous concept which were discussed by us. Okay. So, the recapitulation is of the previous class is what we have discussed. I explained to you about the concept of atomicity with examples and showing images of some atoms so that you can understand the atomicity concept very easily. Is it? Okay. Then I also discussed about the types of atomicity of molecules with examples. How many types of atomicity molecules are there? Monoatomic, diatomic, triatomic, tetraatomic, polyatomic. These are the types of atomicity of molecules are there. So how we can distinguish them, I explained you on that class. Okay, students. So I also explained you about the concept of structure of atom very shortly, because by knowing the structure of atom only we can understand the next coming concept. Okay, students. So I have given a simple information about the structure of atom. Okay. Then we entered about the concept of valency, the new concept, by taking some examples. So how they combine, what is the importance of valency, that one also I explained you. Because of the valency only they are getting stability in the nature. Okay, students. So I explained you in that class. Next, we also explained about the concept of ion and also its charges, and shown some images of molecules and compounds, how the atoms are getting positive and negative charges, which one are called cations and which one are called anions. Cation has positive charges and anion has negative charges. These are all discussed in the previous classes. Okay, students. So today we are going to discuss about the few subtopics which are related to the same lesson, atoms and molecules. Okay, students. Shall we start? Okay. So today we are discussing the first topic, that is molecules of compounds. Already we know what we call molecules, means how the molecules are formed. They are formed by the group of atoms. Okay, students. The group of atoms means it is the number of atoms. So in that molecule only we can divide the elements and compounds, means molecules of elements and molecules of compounds. So molecules of compounds. After that, first we will take the simple information about molecules of elements. What are molecules of elements? Means same type of atoms will present in the molecules of elements. For example, O2, H2, N2, Cl2. Hydrogen, nitrogen, chlorine, oxygen. These are called molecules because they are forming with the same type of atoms. And what about compounds? Molecules of compounds. They are forming different types of atoms. Okay, how they are forming? They are forming different types of compounds. So, molecule of a compound means two or more atoms of different elements. They are forming with different elements combined together in a definite proportion. Means they follow the definite proportion, the perfect ratio by mass to form a species that can exist freely. By combining them only we can get the particular compound. Okay students, for example, what is the formula for H2O? Sorry, water. H2O. Is it? So the formula for water is H2O. So here H2O means two hydrogen atoms are there and one oxygen atom is there. So must and should every water molecule has the definite ratio, means definite proportion, that is two hydrogen atoms and one oxygen atom for every atom. So if any case, if the hydrogen atom and oxygen atom are in 2, means hydrogen atom 2 is there already. If the oxygen also taken 2 atoms of oxygen, then what will happen? The new compound will form, means H2O2. H2O2. So that is a new compound, that is not a water molecule. It form a different compound that is called hydrogen peroxide. So they must follow the definite proportions to form a new compound. Okay students, let us see the examples of images. That is NH3 ammonia, means 1 nitrogen atom and 3 hydrogen atoms are there. Just like carbon dioxide, a molecule of carbon dioxide CO2, and H2O molecule already I explained you. Then HCl, molecule of hydrogen chloride. So in this way the molecules of compounds will form by following different types of elements and following the definite proportions. Okay students. Okay, let us watch some table which are related how the elements are combined to form a compound with different proportions. See here, water. Water is the combination of hydrogen and oxygen. That is 1:8. Okay, then ammonia, nitrogen and hydrogen. I show you the image itself. Okay, that is 14:3. Carbon dioxide, carbon and oxygen, 3:8. Calcium oxide, calcium and oxygen, 5:2. Then magnesium sulfide, that is magnesium and sulfur, 3:4. Sodium chloride, sodium and chlorine, 23:35.5. So in this way the ratios are formed to the compounds. Okay students, so this is the molecules of compounds concept. Okay, then we will discuss about the chemical formula of compounds. How to write a formula for a compounds. Okay, so already we learned how to write the symbols for an element. Okay students, and also already we also learned how to write the symbols for a molecule also. We also learned everything, how to write the symbols for elements, for compounds, and also how to write the letters for the elements, molecules and compounds. Already we all learned in these one in the previous classes only. Now we have to learn a new thing, that is chemical formula of a compounds. If you have taken a dissimilar elements, Dissimilar elements means different elements, and combining them to form a compound. You have taken different elements and combining them to form a compound. Now I am asking you to write the chemical formula for that compound. How will you write? That we are going to learn how to write the chemical formula of a compound. So we are going to learn how to write the chemical formulae of a compounds. Okay, students? Okay. So first of all, keep in mind that while writing the formula of a compound, we must keep two things. What we have that? Let us see. First, we must see the elements which are present in a molecule of the compound. First, we have to observe what are the types of elements present in a compound. Then, second one, we must see the number of atoms of each element present in that molecule. How many atoms are there in that molecule also we have to observe. Means we have to observe the symbols of the element and the atoms of that element. So we have to keep these 2 points. Okay, students. So if the molecule of a substance contain only one atom, subscript need not be written in the formula. For example, I will explain you this by taking this example. That is, 2 atoms of hydrogen. We have taken 2 atoms of hydrogen and 1 atom of oxygen. And by combining these, we get a water. That is water molecule. How we write the formula? H2O. Okay, students. So here, first of all, to write the formula, first of all, we have to keep which type of elements are taken. Hydrogen and oxygen. So, how many atoms of hydrogen has taken? 2 atoms of hydrogen and 1 atom of oxygen. So, here we have to write 2 atoms of hydrogen means H2 and 1 atom of oxygen. So, here 1 is not a subscript. So, we don't need to keep a subscript of 1 to the oxygen. It is naturally indicated that oxygen is a 1 atom. So like this we can write a chemical formula of a compound for a simple element, for a simple molecules. Okay, students. If you want to write different types of, means if you want to write the chemical formula for different atoms, means 2 or 3 or more atoms, then which type of method we have to follow? Means crisscross method. This is the new method to you. It is very useful to you to write the chemical formula of a compound which will form by 3 or more atoms. 3 or more atoms. Okay, students? Okay. Now let us learn how to write this one. So, writing chemical formula of a compound in crisscross method by using valency. Okay, students? Okay. So, we have to keep valency concept in your mind to write the chemical formula. So, it is become very easy to you. Okay. First of all, what is the first point? Write the symbols of each atom or a group of atoms side by side. Usually, the cation first and the anion next. Means cation means which will donate the electrons. Already I have informed you what are cations and what are anions in the previous class. Okay, students. For example, here I have taken you sodium and carbonate. So, first of all, we have to write the symbols of that atoms. Okay, side by side. So, first has to write the cation which is going to donate the electron, and the second one is anion. You have to follow in this way. Then Next step is write the valency of each atom or group of atoms, the top of its symbol. Means, see here. So, the valency of sodium is 1 and the valency of carbonate is 2. Okay, so we have to write their valencies on the top of their atoms. Okay, students. The next step is divide the valency numbers by their highest common factor, if any, to get the simple ratio. If you get the highest numbers in the valencies, means 8, 6, 12, 7, 6, like that we get its highest numbers, then we can divide them with the common factor. Otherwise we will leave it. Just like here, we get a simple ratio only, that is 1:2. So need not be divided here. Okay, students. So then interchange the valency and write the numbers as the subscripts to right side of the constituents as their subscripts. So we have to interchange their valencies one to another, and we have to write their valencies in the subscript, means down of the symbol. Okay, here I have given you Na2CO3. So here Na2 is the valency of carbonate, then and carbonate CO3 1 is the valency of sodium. Okay, so 2 is the valency for carbonate and 1 is the valency of sodium. So here we have interchanged their valencies to one another. Okay, students. See here, I have given some images, examples to you how to write this one. Like this, then we have to write the symbols for chemical formulas. So calcium oxide. So calcium has 2 valency and oxygen has 2 valency. Okay. So they are interchanged, the Ca2O2. By common factor we can cancel it and we can write it as CaO, calcium oxide. Okay. Then see here, iron hydroxide. How we can interchange there? You can follow in this technique we also. Means simply writing the chemical formula by understanding this one. Write a symbol. Remember charge. Means what are cations and which one are anions. Then cross their charges. Charges are nothing but valencies. Okay. See, aluminium oxide. You can follow this method easily for a better understanding to you. Okay. Copper sulfate, calcium sulfate, ammonium sulfate. Like this way we can write the chemical formula by following crisscross method. Okay, students. Then what is the next one? If any constituent receives the number 1, ignore it while writing the formula. So here if you observe it here, so for sodium chloride, sodium has valency 1 and chlorine has valency 1. In this case we can ignore their charges because both have the common factor, that is common valency, that is 1, 1. In this case we can ignore their numbers and just keep write as NaCl. Okay, students, like this. See here, if any element, if any atom get the charge 1, then we can ignore that charge and write it as simple symbol. Okay, here see, for MgCl, so here MgCl2 has, write the formula, chemical formula. For Mg, we get the charge 1. So here we are ignoring that one and writing as MgCl2. Okay, students. If a constant has more than one atom, enclose it within a bracket. If it carries 2 or more, mention as subscripts. For example, see here. So here, if constant has more than one atom, means it is carrying combining of two atoms, they are forming, like that carbonate means carbon and oxygen. So for a particular that type of compound, we have to take it in a bracket and we have to mention the valency out of the bracket. Okay, students. So I have given some table to you how to write a chemical formulas. See, for silver chloride, sodium hydroxide, barium chloride, BaCl2, calcium carbonate, CaCO3. Okay, like this we can write the chemical formulae for some compounds. Okay, students. Now our next topic is atomic mass. What is atomic mass? Are you able to find the mass of an atom? Or we can see the atom with our naked eye? No, it's very impossible. Already we discussed this one in the previous class itself. So atom is a very smallest particle. We can't see that one with our naked eye. Now how to find that mass of that particular atom? Let us discuss it. Okay. So if when we are trying to buy something, if we went to any shop, then at the time when we are trying to buy something, we usually want a specific amount of it. Means for 1 kg, 2 kg, we will ask like this for certain things. Okay, students. So for examples, when we want to buy rice, we measure it in a kilograms. So we will see that the shopkeeper used a balance to weigh the rice. So like this we buy the things from the shop. Similarly, we measure the types of goods by balance itself. But the same can't be applied for atoms. No, we can't weigh the atom's weight by using the balance. So an atom is a very small, so that we cannot determine its weight in units like kilograms or grams. So for finding the mass of an atom, we need a different standard. We don't have kilograms or gram symbol for atom. So we want a definite standard form to weigh the atom mass. So here we will discuss that one, atomic mass. So mass of an atom is called atomic mass. Already we know this one. Okay. Now since atoms are very small, consequently actual mass of an atom is also very small. So atom is itself is a tiny particle. Then the mass of an atom, it becomes very small compared to the particle size also. Okay. So for example, the actual mass of an atom of hydrogen is equal to 1.673 into 10 to the power minus 24 grams. So for one atom of hydrogen. Okay students. So this is equal to 0.0000001673 gram. To deal with such small number is very difficult to us. So it becomes very difficult to us to find the atomic mass of a hydrogen. For that convenience, for our convenience, we invented a relative atomic mass, so that an atomic mass is easily find out. Okay, so let us know the topic relative atomic mass. Okay students, so what is relative atomic mass? Let us see. So the relative atomic mass of an element is the average of mass of one of its atoms relative to 1 by 12th the mass of one atom of carbon. Okay, so means here, for example, atomic mass is the actual mass of electrons, protons and neutrons. So if you take hydrogen, if you will take the hydrogen, then it is the lightest element and has atomic mass of 1 AMU. So atomic masses of other atoms were then measured relative to the mass of an hydrogen atom, but it is very small comparing to other atoms. So later on we introduced oxygen as a standard. It is also become very small comparing to other atoms. Then finally they have taken carbon 12, that was the correct chosen as a standard for calculating the atomic mass. So if you divide the carbon into 12 parts, then 1 by 12th of the carbon is the atomic mass of that element. Okay students. See here, relative atomic mass formula is average mass of an atom into 12 divided by mass of one atom of carbon 12. Okay, then it is a formula for relative atomic mass. So most elements have more than one isotope. Isotope means I will explain you in the next slide. Okay, so more elements, nearly some 118 elements are there to us. In that, more than one isotope is there for every element. So the relative atomic mass of that element is the average mass of the isotopes, taking into account of the abundance of each isotope. Okay, now let us learn about the concept isotopes. So it is very related to you near next coming concept. So isotopes, what are isotopes? Isotopes are the atoms of the same element which have different mass numbers due to different number of neutrons in each nucleus. Means the atoms which have more number of isotopes, for that isotopes which has different mass numbers, with different neutrons in each nucleus. For example, so in the nature, most elements exist is a mixture of isotopes. So the relative atomic mass of a chlorine is 35.5. That is, chlorine has two isotopes. It exists in nature in the form of diatomic molecule. Okay, students. So here, if you observe it, so the atomic number is same here, but but different mass number is there for two chlorine atoms. It is 35 and 37. So chlorine has two types of isotopes. Like that, carbon also have 12 types of isotopes. So we have taken a standard weight of carbon to find the atomic mass of other elements. Okay, students. So the isotope of mass 35 is present in the large quantity. So by adding 35 plus 37, we get the value 30.5. So it is the average mass of that chlorine. Okay, students. So the number of times of one atom of a given element is heavier than 1 by 12th of atomic mass of carbon 12 is called its atomic mass. So one atomic mass unit, that is atomic mass unit, is referred as AMU, is defined as the mass exactly 1/12th the atomic mass of carbon 12. Means if you take any weight of that atom, then we can divide that weight of that atom by 12 and we get the atomic mass of that element. Okay. So mass of C12 atom is 12 AMU. So 1 AMU is equal to mass of one atom of C12. That is, mass of one atom of C12 is equal to, we can take it as 1.99 into 10 to the power minus 23 grams. And we can divide that mass of an atom by 12 and we get 1.66 into 10 to the power minus 24 grams. So on rearranging, 1 AMU can be written as 1 by 12th the mass of one carbon 12 atom. Okay. See, according to latest IUPAC, means International Union of, taken as mistaken, pure. You have to take it as pure and applied chemistry. Recommends that AMU has been replaced by U, which is known as nowadays unified mass. Okay, students. So according to IUPAC, we are using today U instead of AMU. U means unified mass. Okay, students. So atomic masses of a few elements. Let us see. Hydrogen 1, carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24, aluminium 27, phosphorus 31, sulfur 32, chlorine 35.5, potassium 39, calcium 40. Like this, some atomic masses are there for some elements, and you can observe in the images that how we can write the atomic number, atomic symbol, and atomic masses. Okay, for helium, atomic number is 2, atomic symbol is He, and atomic mass is 4.00. In the same way, for copper, atomic number is 29, symbol is Cu. Cu means copper, and atomic mass is 63.55. And what is the C? C refers carbon. So atomic number is 6, symbol C. Atomic mass is 12.011. So here we can have 12 types of isotopes for carbon. Okay, students. And for oxygen, see, atomic number is 8, symbol of the element is O, and atomic mass is 15.999. In this way, we can calculate the atomic mass of that element. Okay. See, so this is the video of this class. Okay. In this video, we discussed few concepts of atoms and molecules. So you can take a worksheet for this class. Okay, students. So these are the questions to you which are related for this class. A chemical formula is also known as molecular formula. Okay. Then explain the relative atomic mass with an example. I have given you in the slides itself what is the definition of relative atomic mass, and you can take any example with your own. Okay. Then third question, define atomic mass unit. And fourth one, write down the formulae of sodium oxide, aluminium oxide, sodium sulfate, magnesium hydroxide, copper nitrate, magnesium chloride. Okay. Then fifth question is, what is meant by the term chemical formula? So you have to write the definition for chemical formula here. And write down the names of compounds represented by the following formula. You have to write the name of the compound. I have given you some formulas to you, and you have to write the names for that formulas. Okay, students. Then how you can measure the mass of an atom? So you have to write the unit of that atom. Okay. So these are the questions to you. You have to complete it in your notebook. Okay. Thank you.